In this video, I want to show you that we can describe the same line using different direction and position vectors. So notice that in these two pictures here, that the dotted line is the same line. In fact, it's the line y equals negative x plus 1. So looking at just the picture on the left, I'm going to draw the line described by r1 of t. And the blue direction vector is that vector there. The red position vector is that vector there. So starting with t equals negative 1, we have that one. We shift it up. And then the sum draws that point there. The green vector points to the vector r1 of negative 1, which is this thing here, the vector 1, 0. Now turning our attention to t equals 0. In this case, the direction vector, the blue vector, you think of 0 times the blue vector, it's the same vector, but it has 0 length. So in fact, it's just this dot. Moving the dot just to there, drawing the green, we have that. You see that we point to the point 0, 1. And so r1 of 0 is the vector 0, 1. Now turning our attention to t equals 1. You can see that when t equals 1, right, we have in fact just that vector there. Moving it to there, doing the vector sum, you see we get that point there. That's the point in negative 1, 2, and r1 of 1 is the vector negative 1, 2. All right, so the thing to see here at negative 1 we had 1, 0. At 0 we had 0, 1. And at 1 we had negative 1, 2. This is t equals negative 1 gives us that point. T equals 0 gives us that point, and t equals 1 gives us that point. Okay, now let's move over to r2. Let's see how r2 of t draws the same line. And again, this blue direction vector is that direction vector. The red position vector is that position vector. Now let's turn our attention now to t equals negative 1. T equals negative 1, we draw our direction vector in opposite direction, move it over. Now the vector sum is in fact points at that point there. So r2 of negative 1 is the vector 0, 1. We see that in the table there. Now turn our attention to t equals 0. Again, 0 times the direction vector, the blue direction vector, reduces the direction vector to just a point, moving that point to the end there, to the terminal point of the position vector, and then drawing our vector sum, we get that. You can see that R2 of 0 is 1, 0. Okay, so it draws that point there. Okay. Now turning our attention to t equals 1. That's that vector there. We move it, drawing our vector sum. We point to that point there. That's the point 2, negative 1. So R2 of 1 is 2, negative 1. And similarly, the point that I want to make here is, let's see, when t is negative 1, we have over 0, up 1. There. When t is 0, we have over 1, up 0. And when t is 1, the sum gives us over 2, down negative 1. So we draw these points here. All right, so now think about what's happening as t ranges from negative infinity to infinity. Right here we see these 3 points in the left-hand drawing. As t ranges from negative infinity to infinity, notice that things are drawn in this, that the line itself is actually drawn in this direction. But in the right-hand drawing, the line is actually drawn in this direction. So the point here is that even though it's possible to describe a line with two different, in 2 different vector forms, one vector form may draw the line in a different way than the other vector description.